right, so we're going to do the second hypothesis test now for a population portion P. So here's the problem. A greetings card company such as like Hallmark or American Greetings is concerned over the percentage of people that sends Christmas cards in the mail. Why? Because in order to turn a profit during the season, the company needs more than 15% of all the households in the U.S. to still send a Christmas card in the mail. So this is a pretty big concern for them. So the company randomly selects 400 U.S. households and finds 80 still sends a Christmas card in the mail. So test at the 1% significance level. So notice here, I changed it from 5%. Before I think I stated it like 0.1 and I called it alpha. Now I state it as a percentage, which I can. And I'm going to call it the significance level now. So test at the 1% significance level if more than 15% of all households in the U.S. still sends a Christmas card in the mail. So we're testing some sort of percentage here, right? All right, let's go through the particulars here. How do we know to conduct a hypothesis test here? So it says in the problem, test, right? And so when you start to see things like test at the 1% significance level, why? Because significance level deals with, hypothesis testing, right? So we're not constructing a confidence interval hypothesis test here. Variable, does a household still send Christmas cards? Okay, yes, no type question, right? Categorical. The sample, can you identify the sample here? It says here the company randomly selects 400 U.S. households, so there's N for the problem. There's 400, okay? And what would be a success? Population. What's the population here? All U.S. households, if we're looking at 400 U.S. households. So remember, hypothesis testing is always about a population of some sort, and we're testing some sort of parameter with regards to that population, okay? So we're testing some sort of percentage that's coming from here, all U.S. households. All right, now what's a success? Finding a household that still sends Christmas cards, right? And so if we find a household that does that, success, right? And how many successes do we have here? And it says finds 80 still sends a Christmas card in the mail, right? And so the number of successes, X is 80. So what can we calculate with X over N? That's P hat, right? The sample proportion. So the proportion within our sample. Is 80 X over N, 80 over 400. And if you put that in your calculator, that turns into 0.2 or 20%. So what is that telling us? 20% of our sample of 400 U.S. households still sends Christmas cards. Okay? All right. So we got our background information. Let's go through the steps. State the null and the alternative hypotheses, right? So we start with the alternative a lot of times because that's what's stated in the problem. So what are we testing here? If more than 15%, right? So you got your option, okay, population portion P. Now P hat, population portion P is either greater than 0.15 or 15%. I don't care. But again, we're going to be using that 0.15 in the problem. Why? Because H sub 0 will be P is equal to 0.15, all right? So I personally like to state it as a decimal because I know I have to throw it in my calculator as a decimal because now P sub 0 is equal to 0.15. So we know that right there is P sub 0, that value, okay? I'm just reminding you this is a right tail test. Why? Because we have a greater than sign in the alternative. When does that come into play? Calculating your probability value, your p-value. Step number 2, check the conditions. Okay, so we need a random sample of some sort or an experiment. Let's see here. The company randomly. There we go. Check mark. Verify the central limit theorem applies and that the sampling distribution of p hat is approximately normal. Okay. So we got to verify that n times p sub 0 and n times 1 minus p sub 0 are both greater than or equal to 15. Remember, that's for hypothesis testing. All right. And so remember, for confidence intervals, it's slightly different. I'm going to keep on reminding you as we go through these problems. All right. And so we got to do the calculation. We got to do n times p sub 0. That's 400, I believe, times our 0.15. That's 60. That's greater than or equal to 15. So does that sound familiar to everybody? Okay. Oh, I didn't mean to do that. That was erroneous there. All right. There we go. Okay. So remember the 15% in the null hypothesis. Remember n was 400. that's 60. That's greater than or equal to 15. We do the other calculation, we get 340. All right, so we get 400 times 1 minus 0.15. 340, that's certainly greater than or equal to 15. Check mark, right? What does that mean? Since both are greater than or equal to 15, the central limit there implies sampling distribution of p hat is approximately normal, and we can use the formula that we've been using. Okay. Step 3, calculate the test stat. Now the good thing is that on the test, we don't expect you to remember every step. What we're going to do is we're going to say, hey, calculate the test stat here, or calculate the p-value here. So that's the good thing about the exams, okay? So there's our test stat, all right? And remember what you're going to need for the test stat. You're going to need p sub 0, right? You're going to need p hat, you're going to need n. So I'll remind you of those things, all right? So n is 400, p hat was 0.2. So plug it in, right? Get your calculator out and pause this. See if you can calculate it on your own first. Put in the numbers and write them all down. Put them in your calculator. See if you get what I get. Pause the video and come back when you're done. So hopefully when you put all that stuff in here, I got a p hat of 0.2, 0.15, right? 0.15, 400. Hopefully you see where all the numbers are coming from. And when I left all the values in my calculator, okay, I came up with a test stat of 2.80. That's telling me that p hat is greater than the value in the null hypothesis by how much? 2.8 standard errors. And so that's my interpretation here. Okay, so interpretation of the test statistic is that the sample proportion, our p hat from our sample is what? 2.8 standard errors above the value in the null hypothesis. All right, there's your interpretation. Okay, well, we got to determine if that's really far away, and how do we determine? There's actually two different ways, and we're just showing you one. We're just showing you the p-value way. Okay, so that's the next step, is to calculate the p-value. So there's our test stat. What else are you going to need with that p-value? Remember, you're going to need to know if it's either left or right-tailed. And so as a reminder, we had a right-tailed test. Okay, why? Because we have the greater than sign. Right-tailed, that means we have to figure out the area. Let's see if I could, well, I can do here. Well, that's not too terribly bad. There's z, here's 0, all right, here's 1, here's 2, here's 3. So 2.8 is way down here, and so right-tailed means that we're just going to figure out the area to the right. And does that look like I shaded in a whole lot underneath that curve? No, that means our p-value is going to be low. That's why we're doing this. That's why I'm showing you this graph, is to visually show you the p-value, that we should not be getting a high p-value. Because remember, when you look up 2.80, what's it going to give you? It's going to give you this unshaded part. It's going to give you that, and that's going to be a large that's going to be a large value as far as probability goes. Okay, we should be getting a small p-value here. So let's take a look. 2.80. 2.80, right? Because here's the 0 up here. So 2.80. You can find we got 0.9974. 0.9974. But is that our answer? 0.9974? No, that's this part right here. 0.9974. Does everybody see that? Okay, 0.9974. All right, but that's not our answer. Now again, you could use the idea of symmetry if you understand how to do that. Okay, but be careful. And so what's our p-value here? It looks like it's 0.0026. Pretty small p-value. Okay. Anytime you start getting below 0.05, and certainly below 0.01, you got a lot of evidence of what's going on here, and that the null hypothesis is probably incorrect and the alternative is correct. Okay, which leads us to our conclusion, right? So our conclusion. So a reminder: if the p-value is less than or equal to the significance level, okay, alpha, we're going to reject the null. All right. So a lot of times in practice, this is set to 0.05. Okay, you'll have to figure that out for your own particular industry. Where are they setting that? Okay, but for right now, we're going to move it around in the problem. Here, we've set it. Okay, I'll remind you what that was in here in a little bit. Okay, so if the p-value is greater than the significance level alpha, do not reject the null hypothesis. Never accept that the null hypothesis is true. Just reminding you of that. So here, the p-value is really, that was 0.0026. Remember that? So let's go back, right here, 0.0026, right? So we got a p-value of 0.0026. Our alpha that was stated in the problem was 0.01. You remember that? Let's go back if you forget. So test at the 1% significance level. Uh-oh. Gotta get rid of that. So test at the 1% significance level, right? All I did was change it into a decimal so we can compare decimals here, okay? So I changed that 1% to 0.01, okay? So let's see. 0.0026 is less than 0.01, okay? So if you ever have trouble with this, I'll give you a little hint. Now, I apologize if you're already good with decimals, and you can easily do this, okay? You know, since this is in terms of 2 decimal places, just take a look at the first 2 decimal places, okay? You can kind of almost forget about this, okay? It's 0.00 less than 0.01. Well, yeah, okay. That means that it doesn't matter that whatever values after that. We know that the p-value here is less than 0.01, okay? And so what are we going to do? We're going to go ahead and do what? We're going to reject the null hypothesis, okay? All right, so just trying to clean up some stuff here. So decision about the null, reject the null, right? We think it's wrong. So we think this statement in the null is wrong. And what does that mean about the alternative? The researcher's hypothesis? The researcher's hypothesis is probably correct. And so, conclusion, interpretation. We have strong evidence. When you reject the null hypothesis, you're going to start off with this. We have strong evidence. We have sufficient evidence. We have statistically significant evidence at the 1% significance level that the percentage, right? What were we testing? We're testing if P was greater than 15%, right? More than 15%. So we're just putting that in words. We have strong evidence that the percentage of all U.S. households that still sends Christmas cards is more than 15%. And so the company seems that, you know, based upon their market share and stuff like that, out of that 15% that are sending Christmas cards, so many are going to go to these different companies, and these companies think they can still pull a margin during that particular season. All right. So hopefully that works well for you. We're going to go through a third one, and let's see. We went through a left-tailed. We went through a right-tailed. What's next? A two-tailed. That's the next one. Thank you for your time.